I'd like to begin this presentation with a note that this work has been a unique one, unique in the sense that there have been attempts in the past to analyze DDC notations automatically, but they're not really been successful as this one. So the results we have today, I would say, is due to the consistent work of a colleague, Dr. Ulrike Reiner, over many years. And she just retired recently. And thanks to her perseverance, we can now do more with the DDC notations we have in our catalogs. I won't get into the technicalities of the coli-ana tool and software in this presentation. My focus will be more on what is the project coli-ana is about, how and why it came into being, and the Dewey Decimal System, the challenges this system poses for such a task, and we'll have a brief look in the coli-ana workflow, and we look at the results and also the implementation at the VZG. So we'll begin with what is Colibri project, because as the name Coli, it's an abbreviation of the Colibri. And so Colibri stands for Context Generator and Linguistic Tools for Bibliographic Retrieval Interface. So this project was initiated by Dr. Ulrike Reiner back in 2003. And since then, it has gotten non-stop funding by our organization, the VZG. So one should also mention for so many years, this project could be a successful one. Right. So the Colibri put forth back then 3 research questions. I will read out these to you. The first one is it possible to classify automatically bibliographic title records using DDC? Is it possible to analyze automatically molecular DDC notations into atomic DDC notations? Is it possible to improve automatic classification and retrieval by means of atomic DDC notations? Please note, these terms, both molecular DDC notations and atomic DDC notations, aren't part of the formal Dewey Decimal glossary. So these terms were coined by Ulrike Reiner for the project. So the molecular DDC notation is a notation that can be syntactically decomposed into many atomic DDC notations, or we also call it dinos. So an atomic DDC notation can't be decomposed further or analyzed further. So if one does try, it doesn't give any meaning. So these, to address these research questions, we came up with 4 projects were created. The one is the coli-ana for automatic analysis, the topic of the day. And then we have coli-conc to create concordances. And then a coli-cor that checks the correctness of the DDC, and coli-auto, which is an automatic classification, still in the pipeline. The Colibri project has its focus always on DDC. Why is it so? You will look at the other next slide. So DDC has been, so I would say one of the foremost reasons here is DDC has been actively in use for over a century. And many of you must be knowing that it was conceived by Melvil Dewey in the late 19th century. And however, it was based on a German decimal system back then. And over these 100+ years, it has grown to have a huge user community worldwide, so in many countries. So it has translations in many languages and has many editions to it. So the recent one is DDC 23. I think the 24 edition is on work. The next point here is the Dewey Consortium in 2000, which was founded, and VZG was member of this consortium. The goal behind it was to introduce and promote DDC in German-speaking countries. And DDC has a strong representation in Europe, and VZG is also a member of this DDC user group in Europe. So this all comes with the responsibility towards DDC. So it is a live system, a very dynamic system, which creates, so every day new notations have been in the system. In our catalog, Union catalog, there has been, or we have at least 10 million DDC notations that currently, and most of them come from external data and sources. like WorldCat and Library of Congress. Just have a look into now, how does this? So it has a notational hierarchical structure like many other subject indexing systems. The notations are made of Arabic numerals from 0 to 9, each representing a subject area, as you can see here on the screenshot above. So 0 stands for computer science, information and general works, and 9 for history and geography. And the first 10 classes are followed by the 100 classes at the second hierarchical level, and then this is followed by the 1,000 classes at the next level. So basically it has a main schedule with these classes and 6 tables. So this is a simple form of it. A DDC can get longer than 3 digits, and if it does, then it is preceded with a point, a dot. And we have here a few examples. As you can see, the longer a number is, the more specific it is, because the DDC does allow to build very fine DDC numbers to specify a topic as accurately as possible. So at times, as you can see, then it can get very lengthy and complicated. And for a normal user, it could seem weird and almost surreal, I would say. So here you really need a help. So how do these exquisite numbers are created? There are rules and instructions in the system, but you also have a tool now that facilitates number building. The numbers can be synthesized among the numbers in the main schedule, or between the numbers in the main schedule and one of the tables, or all together. So you have enormous possibilities to create numbers, and you have add notes to it, and also internal tables, and etc. and etc. So it is a complex number building system, and that gives space to create any numbers you imagine or you would want to. So we have here to demonstrate a very simple example of this complex system. So to create this, to create a notation for pottery glazing technology, which is 666.444, we take the notation from a main schedule, 666.4 for pottery materials, and add to it also a notation from the main schedule, 738.144 glazing, and just go by the instructions given here. Add to the base number, 666.4, the numbers following 738.1 in this PAN number. And then thus you get this 666.444 for pottery glazing technology. So in this way, a large numbers, DDC numbers, have been created over the decades and have been stored or in the holdings of our libraries as hidden treasures, I would say. Hidden treasures in the sense because we are not being able to use this. They have remained unused, unfortunately, for retrieval, since very few have knowledge about these numbers. Right. So I think now you get an idea of why coli-ana was important and why we needed a tool for automatic analysis of synthesized DDC notations. So when we began this project, the VZG had its own objectives. The first one here is to improve our retrieval. So we wanted to improve our search, or we still want to improve our retrieval system, expand our search possibilities, and make search more easier with search terms. So with the atomic denos, what we get from the decomposition, one could actually filter the search possibilities. So you can ask for titles here, as the example says, titles that are related, for instance, 1940s, and this comes from a decomposed component, or just give the possibilities of to extend a full text search. And the next objective here was to support analysis and enhance subject indexing. So the components of an analysis can be used to map with the elements and components of another indexing system. And thus you can make out what is lacking in the system and enhance the subject indexing also overall. So here too, we have an example for the basic classification 21.3, which denotes art exhibition. This could be mapped to, or is mapped here at the moment, to the 700 700 notation from the main schedule and from the table 1 annotation. So which shows clearly the DDC doesn't have a notation yet for this concept. And the third objective here is to improve the presentation in the catalog. So make it more user-friendly, basically. So the catalog has DDC notations without the captions. So we intend to enrich them with captions and link them with hierarchies and make it more user-friendly, or to say more user-usable. So we have something similar. We have done something similar with the Regensburg-Verbund classification, and we want to do the same also with Dewey Decimal Classification. So now a synopsis on challenges this task poses. As you understand, DDC is an extensive system with over 51,000 classes. So you have seen it as a complex number building system with almost 10,000 instructions that are bundled in 60 rule paths and that have their own patterns. And all these give possibility to build fine and accurate DDC numbers, and also a lengthy and complicated one. So here we have an example of a complete or full analysis of a rich DDC number. I have showed this, the 7-digit, as a base number. So just a note here that the base number aren't always 1 digit. So they can be more than 1 or 2 or 3 digits. But this is always mentioned in the instructions. And in such a rich DDC number, the base number could be more than 1 number. So as the process goes on, the base number keeps changing. So that's my understanding. I think this also adds to the complexity of the analysis, though it's given in the instructions. Yeah, so a brief look in the coli-ana workflow. I've tried to sketch it out in a simple form. So I hope that this gives you an idea how it works. So any input data, DDC numbers we get from any source, basically goes through first a data cleansing process. Yeah, all the duplicate denos are eliminated and incorrect DDC numbers are also eliminated. And then a knowledge base is created from the electronic version of a DDC. So in this case, the edition 23 was used, and only the data that is needed for analysis is extracted from the version and converted into the internal format and stored as facts and rules in the knowledge base. Then the data that's cleansed is ingested into the analysis and in the system, the coli-ana system, which is called VZG. And the analyzer really goes through every digit from left to right and thoroughly. And then the output you get, which is called VZG-gram. And you'll see that in the next slide. So this is how it looks, VZG-gram. It has more information about the rules and the patterns that have been used in the analysis. So a complicated view of the result. Right, so now the use cases. This is just a summary of the objectives I showed you. So we in the VZG now plan the very near future to feed the analysis into a catalog and improve our retrieval system and extend our search functionality. So this is going to look something like this. The slide you see here. We have here an example of it. So again, the 666.444 has the analysis shown in the catalog. However, this was done manually by the German National Library. So all the future simple DDC numbers and the complicated ones will be analyzed with the coli-ana tool and will be enriched with the captions, and hopefully we'll have a better presentation format. Right. So the Colicon team has also developed a coli-ana web service, and this offers you to any DDC number and will deliver you the analysis without all this information on the rules and other information that you saw in the VZG diagram. So, and here each component, as you can see, is linked to the titles of the Union catalog, K10+, and also to a mapping tool, Cocoda. The captions you get at present in 2 languages, in German and in Norwegian. We don't have the rights to show in English yet. So what else? And you have the links to Pika, our internal format, and you see there how these components are recorded in the Pika format. And this is the last slide. So this shows the integration of the coli-ana in a mapping tool Cocoda. So there is a tab for it. Here too, if you look for a DDC number or just browse the system in the mapping tool and select a number, you will be displayed the analysis for you to choose and map with the other systems if need be. Yeah, so that's how it is. So at this point, I like to share information that tomorrow at the booth session, we are going to discuss this mapping tool Cocoda and other projects, Bartok. So if you please join us there if you find time, because your opinions, views, and input will be of great value for work further. So we have a reference page here, list of literature for you to look at later. And and the email contact address if you want to send us a mail on it. So that's it. So now looking forward to your questions.